Okay. Hi, everybody. I'm going to show you how to do, we're going to solve that ANOVA by hand that we did not finish in class last time we met. I'm going to do it in Excel because y'all should have seen me trying to rig up I was hanging my webcam from a lamp. It was crazy trying to get it to where you could see me solve this on a piece of paper. And I said, you know what? It's just as good to show you in Excel. So that's what we're gonna do. If you do want to, if you just gotta see me, and you want me to do it again, just let me know. I'll run up to campus and I can solve it on a blackboard and set something up there. But I'm trying to work from home. So here we are. All right. So recall, this is in the last lecture that we had on ANOVAs. One way ANOVA, one way because we have this one explanatory variable, which in this case. These data are actually from a 1972 paper about word recall in older adults and various memory-enhancing devices. There are actually more treatments than this and even more data. This was just, I simplified it so we could easily do it by hand. So, essentially, you just need to remember what your null hypothesis is and what's your alternative hypothesis, the point of ANOVA. So, your null hypothesis is that there will be no difference among the groups. And these numbers here correspond to number of words that somebody can recall based on what memory-enhancing device they were given, which group they were in. So these were folks who counted words, folks who came up with words that rhymed with what they were reading, and folks that came up with adjectives to describe the words that they were reading, and then the number of words that they could recall. So first things first, let's just orient ourselves to what we're going to have to do. So I have pasted in here the handy dandy equations from Quinn and Keough, which is one of your optional textbooks. So remember, you've got to calculate various terms for various sources of variation, the between group or treatment, so that's the variation because due to the groups themselves being different. Okay, the residual variation, which is that within group variation, which as we talked about before, that is essentially the variation or difference due to chance or sampling error, and then your total. So we're going to calculate sums of squares. Let's just go through each of these first, and then degrees of freedom, and then your mean square terms. So here, for your between group sums of squares, we're going to walk through all of this, but I'm just orienting you. You'll take your group mean minus the grand mean squared multiplied by the number of observations for that group. So you do it for each group, and then you add them all together. For your residual or error sums of squares, you'll take an individual observation minus that group's mean, square it, and then add them together. This just means add them all together, all of them across groups. Okay. Your total, now you can do your total sums of squares by adding these two together. In your last lecture, I told you you could just calculate the total sums of squares and the between groups and then subtract to get your residual. It doesn't matter how you do it. How I'm going to show you today is to calculate the between group sums of squares and the residual sums of squares and then add them together to get the total. Simply because I've also posted a link to a video, and that's how he does it. And so in order to basically keep from confusing you, we're going to do it that way, so you see it done the same way. But know that you still have some freedom to do it in whatever order you really choose, as long as you keep your terms in the right places. Okay, degrees of freedom. So this is the number of groups minus 1 for between group degrees of freedom. For residual degrees of freedom, you take the number of observations in a group minus the number of groups. You add them all together. And your total degrees of freedom are your number of observations minus 1 across groups. Okay, so your mean square terms, simply this is your group sum of squares over your group degrees of freedom. Here are your residual sum of squares over your residual degrees of freedom. And then your F-statistic, which is what we're really interested in, that we will compare to our critical value, is simply your mean square group over your mean square residual terms. Okay. So let's do it step by step. First thing you'll want to do is calculate, I like to calculate means first. So the grand mean is simply all of these observations added together and divided by the total number of observations. So that would be this total over 30, which is 8.3. Okay, you should, while we're doing this, you should stop the video and do this and make sure that you get the same numbers that I do. Because if not, that's just a hint. You know, you need to practice doing this over and over because it's easy to make one small mistake. That's why I also say anytime you do an ANOVA by hand, you should double check yourself in some way. Either rerun it or, you know, work through a problem and check it with Excel if you want to, or check it in R. Because you can actually run ANOVAs in Excel. We're just learning to do them in R because I think that that's useful and that's this computing software we're using. Okay, so let's do the group means. So here I've even broken down the means. So the total here is each of these terms, right, added together, and then the total and the number of observations in this group. So the mean for this group will be 7. For this rhyming group, your total is 69. You have 10 observations, so the mean will be 6.9. Here in the adjective group, the total is 110, and you divide by the number of observations, which gives you an average of 11. Okay, so let's go over here. I've already made an ANOVA table. Anytime you solve an analysis of variance, you should make your own ANOVA table. So you have your sources of variation, your groups or treatments, residual and total, your sum of squares, degrees of freedom, mean square, and your F-statistic. Okay, so let's just do it one at a time. So let's do the group sum of squares, okay? So in order to compute the group sum of squares, remember we're going to take each individual group mean minus the grand mean, square that, and multiply by the number of observations for that group. We will do that for each group, and then we will add them together. So I'm going to do that down here, okay? Okay, so you can just ignore this for now. This is going to be for sums of squares later. Okay, so the group mean here is 7. So we've got 7 minus the grand mean, which is 8.3. I'm going to do this in a few different rows. So here, and then we need to square that times negative 1.3. Okay, and then we're going to multiply by the number of observations in this group, which is 10. So that will give us 16.9 here. We're going to do that for each group. So the group mean here is 6.9. Woo! Minus 8.3. We're going to square that. And then we're going to multiply by the number of observations in that group, which is 10. Okay, we're going to do it for the third group. So the third group mean is 11 minus the grand mean. We're going to square that and multiply by the number of observations in that group. Great. Okay, so now we have to sum them. So we will add these together, and that will give us our group sum of squares. 109.4. That is the group sum of squares value. Okay, woohoo! We got one. So I'm going to show you how to do residual sum of squares. You can, if you want to, you could go ahead and just do the total where you take every individual observation and subtract it from the group mean and square that and then add them all together. You're welcome to do that. But I'm going to show you this because the video I posted, that's what he did, and I think that just to show you see the same things over and over and again, I think that's a good idea. So, plus you should know how to do it anyway. So, here you're going to take each individual observation minus that group mean and square it. All right, so that's why I have this here, because you're going to have sums of squares for each group here. Okay, so you're going to take an individual observation, subtract from the group mean, and then square it. That's why I have this over here. This is counting sum of squares. And this is actually not sum of squares. This is more counting, well, squared deviation. I should put squared deviation. There we go. Because we haven't summed anything here yet, right? Okay, so, cool. Let's do 9 minus 7, right? and then square that. So that's going to be 4. I'm only going to go through a few of these. You should do them on your own, though, to make sure you understand. And if you have trouble, let me know. Okay, so, but we'll do a few. 8 minus 7, and square that. It's going to be 1. You got 6 minus 7. That's negative 1. And you square that. That's 1. Okay, I've actually done these. So you can stop the video now and do them. Make sure we have the same numbers. Again, 7 minus 6.9 and square. Okay, that's 0.01, 4.41, 0.81. Oh, that's wrong. Wow. Oh no. Oh, guys. Okay. I should have background music for this, huh? Okay. And same here. 11 minus 11. Oh, that's 0. Hey. 4, 9, 25. Like I said, you should stop the video, get your numbers right, and check with me, okay? All right, here we is. Okay, so now we're going to sum those squares. That's what we're going to put here. Okay, so let's sum those squares. Oh, fiddle. There we go. Obviously, you're going to add them. Oh, wait, I've already done this by hand. Wow. You know what? Yeah, so this is 40.9. We're adding all of the square deviations here. Okay. Adding the square deviations here. So that's going to be 56. Okay. Now that you have each observation minus the group mean squared, and you're going to sum that within the group, now you're going to sum it among the groups. Ouch, yeah. So you just go, gonna add these numbers here. Oh my gosh, it was so easy. Okay, so that's our residual sum of squares. Oh my gosh, guys. Sorry, I love ANOVA so much. It's so fun. Okay, so how do you get the total sum of squares? It's gonna be like Dora the Explorer. How do you get the total sum of squares? That's right, you add these together. Woohoo. Okay, so let's do degrees of freedom. So for your group degrees of freedom, you're going to take the number of groups minus 1. So there are 1, 2, 3. 3 groups. Sorry, I'm getting silly with this now. Okay, so 2. Alright. So here, our residual sum of squares, that's going to be our number of observations minus the number of groups. Holy kittens, no. Get out of here. Okay, so that's going to be, we've got 30, right? And then 30 is the number of observations minus 3 groups, so that's 27. Okay, degrees of freedom total, which should be these two numbers together, added together, your residual and your groups. You can check and ensure that you're correct by saying, okay, but my degrees of freedom, if I just think about it, it's the number of observations, all of them across groups, minus 1. Well, there's 30, and minus 1, yes, that's 29. We're so smart, okay? So you have a way to check yourself. Cool. So now we have our degrees of freedom. Sweet. Oh my gosh, you guys, can't believe how easy this is. Can you believe? So now, what are we doing? We're just dividing our sum of squares by our degrees of freedom. Okay, so we're going to divide the sum of squares for the group divided by the, oh my Lord, have mercy. Do I want this, guys? I don't know. If it opens something else, I swear. Okay, here he is. So, divided by the degrees of freedom. That is your mean square term for the groups. Okay, cool. So now, let's do the same thing for residuals. Remember, you don't do this for the total. I believe Jade asked this question. It was a really good question. You don't need to do it here because we're really just interested in these. We're not interested in the total variance here. We're interested in comparing the among group to the within group. This is the variation that we can attribute to our treatments. This is the unexplained variation. Okay, cool. So now your F-statistic, all you're going to do is divide group by residual Dooby-dooby-doo. Doo-doo-doo-doo-doo. Holy moly, there's our F-statistic. You did it. Okay, so now we compare our F-statistic to our critical value. And if your F-statistic is greater than your F-crit, you must reject the null, right? So here, a key, we have a larger F-statistic than critical value. So that tells us there is a difference among the groups with respect to how many words these folks can recall. Now, it doesn't tell you where those differences lie or how many there are. That is where post hoc testing come in, which we will do next week. So enjoy your spring break, and unless you're watching this after spring break, in which case, okay, hope you had a good spring break. Anyway, so let me know if you have any questions. You can post them in Schoology. That way, your classmates. I should post a discussion group so that your classmates can benefit from that discussion. And I hope that you enjoyed doing ANOVA with me. All right, bye.